Okay, welcome back to section 2.2, where I talk about what exactly are images. Okay, so what exactly are images? Now, the most basic definition I can give you of an image, it's a two-dimensional, remember flat, representation of the visible light spectrum. Now that sounds like a physics definition, but it's actually, in reality, what it is. Remember, light consists of visible color spectrum, which is this zone right here in the electromagnetic spectrum. And we basically call an image basically anything that basically reflects that light, be it on a piece of paper, which is also an image, a painting, something on a wall, all of those things. Could be something on your computer screen, which is exactly what this course deals with here. Those things are images. And effectively, we'll get into this a bit further, but how computers store images is basically in a grid of pixels, and each pixel has a color, which is how we'll be able to show this on your laptop screen or mobile screen, whatever you're using right now. So how exactly are images formed? Now this goes back to your high school physics work, which you hopefully do remember. But imagine light has been reflected off a tree onto a flat surface here. This is called a film or sensor, if you want to think about it in terms of cameras, or retina in terms of our eyes. And basically, since there's coming at all angles, the image is actually going to be blurred at this point. How do you make it not blurred? Well, you use this. Use a barrier where there's light can only come through this small hole, and this is basically the concept of a pinhole camera. And what happens is that light comes in from all angles here through this hole, projected onto this film, and once this film is at a certain distance, the picture will appear very sharp. And this opening here, this little translucent opening, is called the aperture. Those of you who are familiar with photography will have a very good idea of what aperture means. F-stop. Lower the f-stop, the more light it allows to come in, which is what we want. So image formation. Now, going back to photography again, a lens can now take light from all different angles and focus it at a point on a film to get it in focus. And that's by controlling the lens width here. That's actually how we adjust the focus at this point. So how are images seen digitally? Now, computers store images in a variety of formats. However, they all involve mixing basically colors or hues or brightness or saturation. And the most commonly used one in computer vision is BGR. BGR stands for blue, green, and red. What this means is that in this pixel location right here, location 00, that in your computer screen would be this top left corner. Imagine we have a mix of three colors. If you actually take the magnifying glass, I'm pretty sure most likely you can actually see the pixels red, green, and blue at the corner here. And basically to represent a color, basically colors are just mixes of different intensities of these lights. So yellow, like in this shade here, will actually be red at 255, green at 255, and 255 in this 16-bit range is actually the max color. So basically if all were the max value, you would have white. Green would just simply be red at 0, blue at 0. Brown would probably be a mix of a few of these. I'm not entirely sure what it would be. But that's how we bring color to our screens. And that's how computers store images. Remember this picture I showed you before? Now imagine this is, I believe this was like maybe 20 by 100 or something. I can't remember what I made. But imagine this pixel here is 00. This is also 00, and this is 00 for each color. And the 4 represents the intensity of the blue. The green represents the intensity of the green, obviously. And this number represents the intensity of the red here, 106. So now imagine if all of these were to come together. So imagine all of these coming together and overlapping each other. That is how we represent colors on an image. So this is a flat surface now, and we have an image basically being formed out of this. Now let's talk a bit about arrays, because basically understanding what arrays are will help you visualize, especially when you start doing deep learning, how basically images are stored, what you're looking at. It's actually very, very useful. So if you're unfamiliar with this, pay attention. So imagine a one-dimensional array would simply be one cell of information. Let's bring it up. So it's one line, and each number corresponds to its position on this array. So imagine we have an array let's say it stores my grades. And my grades are basically, let's say 0 was math, 1 was English, 2 was physics, blah, blah, blah. So now, if I just said I want my grades, position 1, it brings up my math grade here. That's what arrays are used for. What about two-dimensional arrays? How would that look? Two-dimensional arrays basically have an X and a Y type feel or look to it here. So now we're able to store more information. So now position 0 on this, let's say this is Y dimension, now has 3 rows here, 0, 1, 2. Now, this is basically this Excel grid. If you use Excel, you should be pretty familiar with this. Now, there can be two-dimensional arrays for images, all right? Now, I'll talk about that very soon. But typically, images are stored in three-dimensional array, and that looks like this. You have X, Y, and now you have Z. And remember before, I told you had 3 colors, red, green, and blue, or BGR, to represent the colors of the blue, green, and red, obviously. So now, these are positions here, 0, 0 on the XY, but now that has 3 attributes associated with it. And this is basically how it looks. It's like a big block, a 3-dimensional block, where you have 3 rows or 3 depths going back, and each XY position basically represents the mix of that. That is how images are stored. Now, I did mention you can have images stored in a 2-dimensional array, and that would be grayscale images. Grayscale images are actually pretty cool and are actually used often, not super often, but often enough in computer vision, mainly because processing a grayscale image is technically 3 times faster. I don't think it works linearly like that, due to all the different matrix calculations your computer has to do. But it is faster regardless, and it's less information being stored. So instead of having 3 rows or 3 depths or 3 columns, not columns, depths, you can consider it going back, there's just one now. And that one basically has the information storing for this here. Okay, so now that you have a basic understanding of what images are and how computers store images, I'm going to move on to OpenCV. And now OpenCV stands for Open Computer Vision. I'll give you more details in the next chapter, but it is critical and very useful in computer vision to know, at least be familiar with OpenCV.